Hi, my name is Lucas Enright, and I'm part of the etching of porous titanium for electroplating project under Nel Hydrogen. Nel Hydrogen is a Norway-based company that develops hydrogen technologies. One area Nel specializes in is on-site hydrogen gas generation, where electrolysis is used to break water down into hydrogen and oxygen gases at the location where those gases are needed. Nel manufactures electrolysis cells so that this technology can be utilized in a simple package. The goal of this project is to improve the manufacturing steps of these cells to be safer and more cost-effective for Nel. A key component in these cells is a porous titanium cathode plate. The cathode plates are etched, cleaned, and plated prior to installation in a cell. The etching process that Nel currently utilizes hydrofluoric acid, which is extremely hazardous to work with. Because of the associated dangers, hydrofluoric acid is expensive to use and expensive to dispose of. This project explored options to improve upon Nel's use of hydrofluoric acid, as well as options to completely replace hydrofluoric acid, such as alternative etchants and different etching methods.
Thanks, Lucas. So in order for us to improve on the hydrofluoric acid current process, we have a couple design requirements. The first thing would be to identify alternative etchants for use in a similar process to the current one. So our objectives for that are to have it cost less than the current process and use less protective equipment. There are many other etchants that will have lower PPE requirements than the current one. And we also want to lower the disposal requirements. Currently, hydrofluoric acid is very costly and very time consuming to dispose of, so we would like to reduce that. In addition, we want to identify general process improvements, so reducing the time required to complete an etch, reduce the overall cost, and reduce the safety requirements. A big caveat to this is we don't want any process improvements to instill more PPE than is already used. For instance, heating certain etchants would require specialized masks that would overall increase the PPE and cost requirements. And the final design requirement our group has is to model behavior of etchants when used on titanium. So generally just model how titanium behaves when etched with certain parameters. And those etchant properties and parameters would be found through experimentation.
For our solution, we did both a literature review and a qualitative model. Our literature review focused on different types of etchants in addition to estimating what would happen if we increased the stir rate and temperature. We found literature to support this. Here you can see the model. Over here are the results of the model. 149 is just a qualitative result. It's not the actual quantitative result. Up here there are the println lines which produced these three results. Note that they are at 25 degrees Celsius, 30 degrees Celsius, and 50 degrees Celsius. The context is that most of these etchants are much less caustic than hydrofluoric acid. For example, hydrofluoric acid would take my hand and reduce it to simply bone and remove all of the skin from it. From an economic perspective, reducing hydrofluoric acid will reduce the cost of safety training for the use of people in Nel, and it will also allow them to dispose of their etchant more safely, causing less contamination. From an ethics perspective, we believe that using a different etchant, such as multi-etch, is much more ethically sound than using hydrofluoric acid, because using hydrofluoric acid results in possible damage, such as the hand that I listed earlier, but it can also result in death.
So my part in this video is to talk about the impact our solution will have to Nel Hydrogen on its usage of hydrofluoric acid. So part of our project is to come up with better alternatives that Nel could use in their productions. So the names of some of these substances that can be better alternatives are substances such as bromide methanol, multi-etch, phosphoric acid, sulfuric acid, and many more. These substances are better alternatives not only because they are A, less corrosive, but B, they are more environmental friendly in terms of they provide less danger to the environment and to the employees overall. Thank you for your time.